In this video, we are going to look at area bounded between the x-axis and a given curve and some applications of those types of problems. So you may recall doing something called Riemann sums where you used rectangles to approximate the area under a curve between that curve and the x-axis. What we know is that if you are integrating between, if you're given an interval and you'll integrate on that interval, that allows you to find the exact area under that curve between that curve and the x-axis. So if we are given the function, in this case, f of x equals -6 plus 5x squared, and we're asked to find the area under that curve from x equal 2 to x equal 3, then we are simply going to integrate that particular function with respect to x. So when I integrate -6, I get a -6x. When I integrate 5x squared, I'm going to get a 5x cubed divided by 3. And then I'm evaluating it from x equal 2 to x equal 3. So we'll have a -6 times a 3 plus 5 times 3 cubed over 3. And then we're going to have to subtract a -6 times 2 plus 5 times 2 cubed over 3. So here we're going to have a -18 plus 3 cubed would be 27. And so if we multiply 27 times 5 and then we divide that by 3, we're going to be left with 45. And then we have a -12 plus 5 cubed is 8 times 5 would give me 40. And then, of course, divided by 3 would be a decimal, so we're just going to have to leave that as 40 divided by 3. So if we continue simplifying, -18 plus 45 will leave us with 27. And then as I distribute this negative, that becomes plus 12, and then a minus 40 over 3. So 27 plus 12 is 39. And in order to combine these, we need a common denominator. So we're going to multiply by 3 on top and 3 on bottom. So this becomes a 117 over 3 minus a 40 over 3. And if I take 117 minus the 40, I am left with 77 divided by 3. So that would be the total area that is bounded between that curve and my x-axis. And that would be from the interval of 2 to 3. So roughly that curve is, something like that. So that area would be 77 over 3. Okay, so now we look at an application type problem. So in this problem, we're given that the marginal cost of a product is given by 264 plus 142 divided by the square root of x. Remember, marginal cost is a derivative of cost, where x is the number of units produced. So my current level was 59 units, and we're going to increase it to 194 units. So we want to figure out how does it increase my total cost. So we are going to be integrating. We're starting at 59 units. We're raising it to 194. And we're going to integrate the marginal cost to get back to the original cost function. So 264 plus 142 divided by the square root of x. And we're doing this with respect to x. Okay, so the first thing I'm going to do is rewrite that square root to make it easier to integrate. So we've got a 264. We're going to pull it up to the top as well. So the square root of x is going to be x to the 1/2 power, but since it was on the bottom, that will make it a -1/2 power. So now I am ready to integrate. So the integral of 264 becomes 264 times x. The integral of 142, x to the -1/2. When I add 1 to the power, that's like saying plus 2 over 2. So that becomes x to the +1/2 power. but then you have to divide by the new power of a half. And then once we simplify that, we are evaluating it from 59 up to 194. So now let me simplify. 264x. Dividing by 1/2 would be the same thing as multiplying by 2 over 1. So up here we do the same, and that would become a 284 times x to the 1/2 power. And then integrate from 59 up to 194. So remember, you actually plug in the 194 first. So 264 times 194 plus 284 times the square root of 194. And then we're going to subtract 264 times 59 and plus the 284 times the square root of 59. And we are subtracting that whole thing. So now I'm just going to get on a calculator. 264 times 194 plus 284 times the square root of 194. That gives me $55,171.66. And then I'm going to do the 264 times 59 plus 284 times the square root of 59. And that gives me $17,757.40. I probably shouldn't round these decimals yet, so let's carry those three. So 55171.662 minus 17757.445. So that gives me a total of $37,414.22. So careful not to round the decimals too early. Always carry one more than what you need in your final answer. Okay, so on this final problem, it was discovered that after T years, a certain population of wild animals will increase at a rate of P prime equal 36 minus 3T to the 1/2 animals per year. So they are asking me to find the increase in population. So again, if this is the derivative of population, if we integrate the derivative, that gets us back to the actual population function. And we're looking during the first 7 years, so we're going from T equals 0 to 7. And in this case, we are deriving with respect to T. So I'll go ahead and integrate. The integral of 36 becomes 36t minus the 3t. When I add 1 to this power, that's like adding 2 over 2, so that becomes t to the 3/2 divided by that power of 3/2. And then, of course, I'm integrating from 0 to 7. So let me go in and clean that up. Dividing by 3/2 would be the same as multiplying by 2/3. So if I come in here and multiply that by 2/3, I'm just going to be left with 6 over 3, or simply 2. So I've got a 36t, and that'll be minus a 2t to the 3/2 power. And then we are evaluating it from 0 to 7. So if I plug in the 7, I've got 36 times 7 minus 2 times 7 to the 3/2 power. And then I have to subtract 36 times 0 minus 2 times 0 to the 3/2 power. So 36 times 7 gives me 252. And then 2 times 7 to the 3/2 power is going to give me 37.04, and then all of that is 0, so minus 0 is still 0. So 252 minus my 37.04 leaves me with 214.96, but of course they say round to the nearest animal, so 215 animals.